Okay, so we've had a look at standardizing some z-scores and calculating probabilities based on these standards. Okay, another way of doing these is you can use your bell curve, and this is especially useful if you can't remember the rules about what's minus and what's plus, whether it's just normal or not. Okay, so what you can do is you can look at your bell curve. So this bell curve, you know that the z-score describes the position of your raw score, that's your x value, your number that you're checking, in terms of its distance from the mean. So we have our bell curve, which we know is like this shape here, and right in the middle we know is the mean. Okay, our z-score for the mean is always going to be 0. Then we can get up to 1, 2, and 3. What these numbers actually are standard deviations. So a number that's here is a standard deviation, one standard deviation from the mean. So that's what your z-scores are. They convert your raw data or your numbers into the standard deviations from the mean. So if you have a z-score of 0.5, it's going to be in here. And it's going to be 0.5 standard deviations from the mean. So, and as it says here, a positive z-score indicates a score that is up here, and if it's negative, it's down here. Now, when we're looking at our scores and our z-scores, what we're actually calculating is we're looking for the areas under the curve. It's complicated, but don't worry about it. What you will see is that for most of the data in any population, so that's 68.2% of the data, lies within one standard deviation of the mean. Then, if you go from a z-score of -2 to a z-score of 2, okay, so that would give you 95.4%. So 95.4% of the population, we say, lies within 2 standard deviations of the mean. And then if we go from a z-score of -3 to a z-score of 3, that means that we are within 3 standard deviations, 1, 2, 3 standard deviations from the mean. So we say that 99.7% of the population lies within 3 standard deviations of the mean. Okay, so if we're going to look at this, oh, this looks quite small here, but let's see. Okay, so if we have probability that z is less than 6.8, so if you go to your standard curve, you have your curve there. Okay, sorry, 1.68, that is. 1 would be probably here, so 1.68 will be here, 2 will be here, 3 will be here, so 1.68 is there. We are interested in this area here. Okay. If you have P of Z greater than 0.85, so that's P of Z greater than 0.85, that's that part there. We can't calculate areas that are bigger. We can only, if you can guess, how do you calculate the shaded area? You calculate the whole area. You take away this part here, and that will give us this area. And that's exactly what we do. The whole area is 1. We take away this probability, which is the probability that z is less than 0.85, and that gives us this. Now, to calculate z-scores that are less, we cannot calculate z-scores that are less here. So to calculate this area here of -1.32 is the same as this area here because the curve is symmetrical. So if I want to calculate this area, it's the same as calculating this area here. And how do I calculate this area? And it's 1 minus all of this. Okay, and that's the calculation done out there. And then if I'm looking for this area here, which is P of Z between -1.21 and 0.93, so I'm looking for this area here. So what I can do is I can calculate this area, take away this area, and it'll give us this bit here. So now when you have that, when you've looked at those, so look at that again, go over that again in your head and see it. So we have to look at these questions here. So what we're looking for here is I want P of Z less than 1.2, straight from the tables. Here you're looking for P of Z greater than 1, so that's going to be 1 minus P of Z less than 1. Here, it's the same as looking for this area here, so it's going to be 1 minus P of Z less than 1.92. And for the last one here, we're looking for P of Z between minus 1.8 and 1.8. The solutions are below.